all these discussion, it is very important to discuss the mitigation strategies. Mitigation strategies in leveraging the distribution knowledge. So, in this regard, the first one is seismic hazard assessment and zoning, fault mapping and paleoseismology. Identify active faults, for example, sagging segments, and quantifying recurrence intervals and form building codes. Bangkok's recognition of distant risk amplification led to post-2007 code updates. Microzonation, what is it? Classifying urban areas by soil property, for example, liquefaction potential guides construction practices. Taiwan's dense seismic network provides data for such assessment in the fold and thrust belt. The second one in this regard is engineering solution and early warning resonance mitigation. Base isolators and tuned mass dampers protect skyscrapers in long period hazard zone like Bangkok and Los Angeles. Now, let me explain you very important factor, that is early warning system. Japan's nationwide alerts provision seconds to minute of warning. Taiwan's systems dictated the Dapu quake within seconds, enabling automated safeguards. Let me also discuss about the policy and community preparedness retrofitting programs in this association. Prioritizing seismic upgrades for schools, hospitals and critical infrastructure. For example, Nepal's post-2015 efforts demonstrate progress through Myanmar's civil war complicates such initiatives. Role of public education is also very important. Drill and awareness campaigns in high-risk regions like Tibet and Indonesia build resilience. So, after explaining the adjacent neighboring countries, let me also now discuss about the India's earthquake danger zone. India is like a building with uneven foundations. The Bureau of Indian Standard (BIS) splits it into 4 risk levels. In this table, you can see the zones have been divided from 2nd, 3rd, 4th and 5th. The 5th is very high. What does it mean? It means crash zone. The key areas are Himalaya, northeastern states such as Assam and Manipur and Gujarat's Kutch. The next zone is 4th, that is considered as a high risk level. It means shaking ground, and the key areas are Delhi, Bihar, Mumbai suburbs. The 3rd zone is of moderate risk level. It means occasional tremors. Key areas are Kerala coast, Chennai and Kolkata. And the second one is of low risk level. It means rare rumbles. The example of key areas are Hyderabad and Bengaluru. It is situated in the central India. Why India is slowly bulldozing into Asia like a truck hitting a wall? This collision created the Himalayas and constant pressure builds up, especially in zone 5th and 4th. For example, in 2001, a zone 5th quake in Gujarat, that magnitude of 7.7, flattened town because the ground shook for 90 seconds longer than a song chorus. Now, what happens when earth shakes? The first one is immediate danger is ground shaking. Building sway like trees in a storm. Weak structure collapses. In cities, what happens? Bridges crack, roads buckle. For example, in 2015 in Nepal quake, this damaged Kathmandu's historic temple. Second one that happens is earth splitting. The ground tears open a long hidden crack which we know as faults. For example, in Kutch in 2001, the crack were 6 meter deep, swallowing tractors. The second one is chain reaction disaster. In this regard, the first one is landslide. Himalayan slope crumble like sand castles. For example, in 2023 in Uttarakhand, landslide triggered by small quake. Another one is tsunami. You may be very well aware of this. Ocean quakes push giant waves ashore. India's east coast faced this risk many times, like in 2004 tsunami that hit Chennai very badly. The third one is ground turning to soup. Wet soil acts like quicksand during shaking. It is also known as liquefaction. In Bihar in 1934, farms sank 3 feet. Fourth one is silent killers. These are fires and water shifts. Gas pipes burst, fires spread. For example, in 1993, Latur quake, wells dry up overnight or flood unexpectedly. So the question is, can we predict earthquake? Scientists can't predict like weather, but they watch for hints. What are these hints? The first one is nature's warning. Ground tilting like wobbly table, random gas leaking from rocks, animal acting restless, dogs barking non-stop. Another examples we can historical instances, areas with past big quake like Kashmir, these are overdue. Another one is technology help. Sensors track tiny land movements but give only a minute of warning. Reality check in Delhi, which is considered as the zone 4th, has 500 plus tiny quakes yearly. The big one could come in 20 years or tomorrow. We never know. So, how India reduces earthquake risks? The first one is building smarter. We can construct the flexible building by using rubber pads under foundations like a sneaker sole which we use in our shoe. Steel frames bend without breaking. Second one is saving old structure. Injecting glue into walls of historic monuments, for example, Delhi's Red Fort. Community armor. In this, early warning system plays a very important role. For example, mobile alerts that was tested in Uttarakhand. School drills. Kids practice duck cover hold monthly. No build zone. Laws ban construction near fault in Himachal. These are very good examples. These are the initiatives taken to combat the earthquake risk. Now, let me also discuss about the government steps, and in this regard, first I will discuss about the NDMA, National Disaster Authority. National Disaster Authority trains village volunteers. In this, micro-zonation is nowadays coming up. This is creating a street by street risk maps for Chennai and for Mumbai. Now, after discussing India's instances, let me also discuss lessons from all across the world. And in this regard, the first one is Japan. In 2011, tsunami walls failed. Now, India builds coastal shelters. In Haiti in 2010, poor building collapsed. India now enforces construction codes. Human mistake that increase risk over crowded cities. Delhi has 30,000 people per square kilometer in quake prone areas. Another concern is dams and diggings. Koyna Dam in Maharashtra caused 1,000 plus small quakes since 1962. Ignoring warning, builders in Dehradun, which is like considered in the zone 4th, skip safety rules to save costs. Tech fighting quakes. Seismometers 150 plus across India detected shakes within seconds like a heartbeat monitor. Satellite eyes. ISRO maps post-quake damage in hours used in Manipur 2016 quakes. Another important technological factor is GPS trackers. The measures Himalayas rising 1 centimeter per year, warning of growing pressure. A is Richter scale. Measuring energy explosions created by Charles Richter in 1935. This uses logarithmic maths. For example, a magnitude of 6 quake is equal to 10 into more power than a 5. A 7 is equal to 100 into more than 5, not just a little stronger. What is the limitation? Works poorly for a huge quake, magnitude of greater than 7 or distant ones. The second one is the Mercalli scale, measuring what people feel. This uses Roman number 1 to 12 based on eyewitnesses report. For example, on first only detected by the instrument, on 6th everyone feels it, dishes break, on 12th the total destruction, ground waves visible. Another one is moment magnitude scale, today's gold standard. Why scientists prefer it? It's because of the first factor, that is the accuracy. This uses satellite data plus rock stiffness calculations. There is no upper limit. Correctly rated Japan's 2011 quake as 9 Richter, underestimated it. Global compatibility used by all seismologists since 1979. So, at the end of this lecture I would say, so the summary is living with Earth's restless crust. The global distribution of earthquake concentrated along plate boundaries yet capable of striking intra-plates regions reflects the dynamic nature of our planet. The events of 2025 underscores that seismic risk is not solely a function of magnitude or depth. It emerges from the intersection of tectonic processes and human vulnerability. The sagging fault rupture caused devastation disproportionate to its magnitude due to urban location and vulnerable infrastructure, while the Tibetan quake revealed the peril of remote, poorly constructed communities. Taiwan's Dapu earthquake, though moderate, illustrated how complex fault geometrics can amplify damage in unexpected directions.